Good evening, everybody. So, I am Chani Dubdunage, and I have Asela Kotakama here with me as well. So, we welcome you all to our TED Talk. And today we are going to discuss about some tips and tricks that we can use to optimize the queries on our SQL Server. We use different kinds of databases in our day-to-day development work and on our production environment. So, in this talk, we are going to focus on the Microsoft SQL Server. So it is a relational database management system, and it was developed by Microsoft and initially released on 1989. So even though this presentation is based on the SQL Server, I invite you to keep listening because you may find interesting things that you can use on your databases as well. So, if we're going to look at today's content, so first, I'm going to introduce you to some metrics that we can use to analyze the query performance on the SQL Server. And next, I'm going to give you some strategies and guidelines on optimizing the SQL Server indexes. And next, we are going to look at some query hints and settings. And lastly, we are going to talk about optimizing the string search on the SQL Server. So, if we begin, first we are going to, let's look at some metrics that we can use to analyze the query performance. So, there are several kinds of methods we can use. So, these are some basic metrics we can use on the SQL Server. So, the first one is we can get the execution time using this statistics time metric. And next we can get our input-output usage of our queries using the statistics IO metric. And also we have some interesting tools, interesting features like query execution plans and dynamic management views provided by the SQL Server, so we can analyze the performance of our queries. If we look at the first metric, it is the execution time or the statistics time. So let me show you a query code snippet so we can practically see what is happening, how can we obtain this statistics time metric? I hope you can see the SQL Server Management Studio. If we run, I'm going to run this preparation step initially. So, if we want to obtain the time statistic, first we have to turn it on. So, we do it like this. And next, we are going to run our query. So, if we run this, in this messages tab, we have some messages regarding our SQL Server time statistics. So, the first one is parse and compile time. So, this is the time taken by the SQL Server to parse and compile our SQL query. Basically, it checks the syntax. So here we can see there is a CPU time of 109 milliseconds and total time of 168 milliseconds. Then the next line, we can see the SQL Server execution times. So this shows the CPU time used by the query, used for this query to fetch data on the processor. So it is the CPU time is for this query is like 1141 milliseconds, and the total time is 4033 milliseconds. And finally, we have something called the completion time. So this is the exact time stamp the query return our results. So we can obtain the time statistics of our queries like this. And finally, if we want to turn it off again, we run this query. So this will turn the statistics time off. And next, we are going to look at our next metric. It is the input-output usage statistic, or the statistics IO. So let me again show you an practical example of using this statistics IO metric. So first, we run the preparation scripts. Sorry. First, we run the preparation script. And as same as the statistics time, we are going to turn the statistics IO on from using this query. And then we are going to run the sample query. And after the query is completed, in the messages tab, I hope you can see a set of messages. These messages mentioned are divided by the table-wise. Messages are divided by table-wise. So if we closely look at this message, there is a set of counts here. So if I explain this one by one, the scan count is the number of seeds. So scans perform at the leaf level of the our final data set. And the logical reads are the number of reads performed on our buffer cache. And physical reads is the number of reads performed on our storage device. So likewise, we also have read-ahead reads. They are the number of pages placed into the cache when we run this query. And also we have the same statistics for our large object binary objects as well. And finally, if we want to stop taking this metric, we have to turn it off again. Next, so we are going to look into the query execution plans. So SQL Server provides us with two types of query execution plans. The one is the estimated execution plan, and the second one is the actual execution plan. So the estimated execution plan is an estimation by the query processor before running the query. So it estimates a query plan, and it gives us here. So if we go into look at the query plans, this is the query I'm going to run. So to obtain the estimated execution plan, we just have to click on this tool, or the shortcut is Control plus L. So if I click this, we can see there are no results here, but we can see the estimated execution plan of our query. So this plan contains what are the indexes we are going to use for this query, and how the tables are going to read, and basically what are the operations the SQL server is planning to do to give us our results. So that is the estimated execution plan. So if you want to look at the actual execution plan, we have another tool. It has a shortcut of Control N. And if we click it and execute our query, after the query is completed, the results are here. We can see another tab showing our execution plan. So here, the SQL Server shows what it had actually done to get our results. So what are the indexes it has read, and how many, what are the processing cost of that index, that step. So we can see it all is here. And so that is the execution plans provided by SQL Server, so we can monitor the performance of our queries. So the final metric we are going to look into today is the dynamic management views. So SQL Server provide some features called dynamic management views and dynamic management functions. So these are basically server state information kept by the SQL Server to monitor the health of the server instance and diagnose problems. So, and also for tuning performance. So there are a large number of dynamic management views. So I mentioned a few here, very useful ones. For example, the cache plans, exec cache plans management view. So it provides the query plans cached by the SQL Server. Another one is the index usage stats. So it tracks how our index are used, so we can identify potential inefficiencies in our queries. Then another one is the IO virtual file stat. So it offers the statistics on IO operations at file levels. And the final one I mentioned here is the active transactions DME. So it displays details on currently active transactions. So here I have another example on an dynamic management view here. So we run the query. So I have used the index usage stats dynamic management view. So we can see what are indexes used in our database, and the data is here, like how many user seeks, how many scans, lookups, and what are the timestamps that operations are happening. So those are the metrics we can use to monitor performance on our SQL Server. So next, we are going to look into the SQL Server indexes, and I'm going to give you some tips and tricks that we can use to improve the performance of our SQL queries. So we all know indexes are the only structures associated with our table or our view that we can use to speed the retrieval of our data. And so Microsoft SQL Server keeps index as an B-tree structure, so we can fetch our values quickly and efficiently. So without talking about the general theories, let's look into some indexing strategies and guidelines. So we know poorly designed SQL indexes and lack of them are also a primary source that hinder the performance of our application and the SQL Server. So let's look at some strategies we can use to improve the performance. So first one is we should avoid indexing highly used tables and columns. So what I mean here is more indexes on a table, the bigger the effect will be on our performance. So if our table has lots of insert, update, delete, and merge operations, and we have a large number of indexes, those operations will have a performance hit. So because we have to manage all that indexes when an operation happens. So we have to avoid like highly modifying tables, columns as possible. And the next strategy we can use is to use narrow index keys whenever possible. So that means we should use as few columns as possible in our index. And when creating indexes, exact numeric keys are more efficient. Like integers, if we build an index on some column that uses integers, that they will be more efficient. And so, like those indexes are also require less displays and less maintenance over it. And the next guideline we have here is we should have non-clustered indexes on columns that are frequently searched and or joined. So this ensures that this means that we have to put non-clusters index on foreign keys and columns that are frequently used in search conditions, such as where clauses, so that they return exact matches. So the next one is create indexes on foreign keys which get modified frequently. So we should put indexes on foreign keys where insert, update, and deletes are performed frequently. So this allows us to update the master table, and so without locking the weak entity. And after those strategies, I'm going to show you another useful feature on the SQL Server. This is called the missing indexes. So we can miss an index that could improve our performance of our queries. So in such scenarios, SQL Server informs us with what are the missing indexes that could potentially help us. So we can see those warnings in the management SSMS GUI and our execution plans, and also on the missing indexes dynamic management view. So if I show you an example of such a missing index scenario, so for this query, first I am running it with all the indexes that it required. And if we get the actual execution plan and run it again, we can see there are no warnings here. So next, I'm going to drop an essential index for this query. And after dropping it, if we run the query again, we can see there is a warning on missing index, and the SQL Server also provides us with the syntax we need to use to create that missing index. So it suggests us to create a non-clustered index on the customer ID column, and also to include another set of columns as an covering index. So it is a very useful feature, but we have to be cautious before acting upon these kind of suggestions, because there can be existing indexes that are similar to this one that could be modified to cover this use case. So we have to check on that. And also we need to think, do we need all that columns? Would an index on the only sorting column be good enough? For an example, here, do we need all the other columns or just the custom ID column? Will the custom ID column only be enough? So if we recreate that index here again, so this syntax we can see we only create it for the custom ID column only. And if we run this query again, and there will be no more missing index warning. And we have only created for the customer ID, and we haven't created that covering index suggested by the SQL Server. So we have to be careful when we act upon these suggestions. And another thing we should consider is how high is the impact of the index. So will it improve the query by 95% or only just by 5%? So we have to consider on that, because that's a trade-off. So we can improve our performance, but the index will introduce a performance hit as well. And finally, we have to check if the index exists already, but for some reason the query optimizer is not choosing it. So in that kind of scenarios, we have to you do something else to use that index. So to talk about that tips and tricks, I invite Asel to continue from here.
Thanks, Nandu. Let me share my screen. So everyone can see my screen. So today I am discussing about the coding and settings, and later I am planning to discuss about string search optimization in SQL Server. So let's move to coding and settings. These are useful for optimizing query performance, and the hints can control the behavior of SQL Server queries overriding execution plans. And settings are scope level configurations. So we can put them in our stored procedures, triggers, and any scope to optimize our queries. So I have mentioned few of them in here. So index node of precompiler, some of the hints, and also at the board no count and no count are some SQL Server settings. So I move on to our first thing that we are going to cover today. So index is the first one. Index forces SQL Server to use a specific index for query. Like Jandu mentioned that when we don't, when our execution plan doesn't use the best index for our query, we can force it using this index hint. So it is useful when the query optimizer doesn't use the best index, like I mentioned before. So you can see in this query, we are selecting the top 20 product IDs with these conditions from the product to category table. So when it doesn't pick the best index, so we have to force the product to category product ID index for this query. So it will be better when we check it. I'm not planning to spend much time here because that will also cover this part. And I'm moving on to Nolop. Nolop is another index, another hint, which allows to read data without waiting for us. So in here, that in this query, you can see that we are selecting the top 20 queries from the contact table, not 20 contact IDs below 20. So when we put the Nolop, this query won't wait for any other operations to be finished in this resource contact table. So when we use this, so it reduces the network traffic, especially when we can use this in the stored procedures with multiple statements. So when the processes are not finished contact table, that there will be dirty reads because this is not the final data in the contact table. So let's quickly move into our next slide. So here we are going to discuss about the parameter sniffing, which is a feature of SQL Server. So this is how SQL Server caches the execution plans based on the first set of parameters and uses it for the subsequent execution. It means when we have a query, named query A, then we run it with the parameters 1 and 2, your service will caches the execution plan A for that query. So next time when we run the query, the same query A with the parameters 5,000 and 6,000, it will run on the same execution plan, the plan A, for those parameters. So there could be a better execution plan for 5,000 and 6,000 rather than using the same execution plan for the 1 and 2 parameters. So we can set up a solution for that using SQL Server means like recompile and optimize. So we will more to discuss about that. So recompile. The recompile process SQL Server to generate a new execution plan every time. So when we put the recompile in any query, so it will generate execution plan and not use the cached execution plan. So it is useful when dealing with the unpredictable data pattern. So I have prepared a small example for this, and let's move on to that. So in there you can see imagine a warehouse worker quickly finding the details for common orders because the system knows the best way to look them up. However, when searching for rare items, the system is slow. So we are going to use the option recompile to perform better for that rare item. So like I'm using the AdventureWorks database, Works 2019 database for this example. So let me clear the DB cache first. And I'll also make the statistics logs on and also the execution plan. So I'm going to run this query for this common product ID. So let's run this. And you can see the execution plan here. So I'm running this for another parameter, the same query with another parameter. So let's run this. And you can see the similar execution plan there because of that parameter snipping. So I'm going to run this with option recompile in a new tab so we can compare the execution plans. I'll take a new tab for that. First, query. So you can see there's a different execution plan and it is not using the previous execution plan for this one. So in there, you can see for this the same parameter here, the execution plan was different, and also for the same parameter, there are in the previous query there are without option recompile, there are 1,000 logical rings there, and for this one there are only 10 logical rings. So typically in this scenario, it will be a better query for this parameter and the query. So let's move on to our next slide. And our next thing is optimize for. So what it does is that it optimizes the query execution plan based on a specific parameter value. So it is useful when the majority of the execution benefit from the optimizing for a particular value. So I have prepared another example for this one also. So here the AdventureWorks sales main business is road bikes. So they observe that querying for road bikes is common, while the others are less frequently queried. So we are going to optimize this query for road bikes. I'm using the same database here and clear the DB cache and statistics. And so I'm going to run this query for less commonly queried value. So when the parameter snipping happens, so it will use the same execution plan for this one also. And you can see here, when you hold on this, the estimated number of rows for all executions is something very high, and the actual number of rows for all executions is 3, which is our result set. So I'm going to run this query with the parameter commonly queried value. So you can see that estimated number of rows and actual number of rows for all executions are similar before. So we are going to run this query with the optimize for keyword hint, and let's see what happens. So you can see here the estimated number of rows for all executions is 43, and the actual number of rows for all executions is also 43, which is the count rows of our data set. So it happens because that this query was optimized for this parameter, and it could be beneficial for some scenarios like we discussed. So let's move on to one slide. So when sync is log out prevents the SQL Server from sending the message indicating the number of rows affected. I think you guys have seen that the rows count is displayed in the message tab in the SQL Server Management Studio when we run a query. So when we set up the log count on, it won't perform for this won't perform process for rows affected. So this is not for hint. This is a setting. Sorry, but for that, this is a setting. So in there you can see that for this stored procedure we have set the log count on for this scope. Our scope is this stored procedure. So it will not show the process rows count in this query. So when we make the log count on, so the like I mentioned, that server processing for affected rows will not happen, and also the network traffic for sending affected rows count will be not there. So it could benefit, we could benefit from this one also in some cases. And let's talk about when to use hints and when not to use hints. So we can use hints when the actual query is inefficient, and also for blocking and deadlocks that we could use for those queries. And also we can use SQL Server hints and settings as an emergency solution. And we could avoid the BMT optimization, which means that we have to know why we are putting this in there and what will be the result of that. So also there will be a maintenance burden enforcing the hints and settings in our queries. So when the data changes and also the process changes, that those queries won't work as expected in the future. So next time I'm going to discuss about the optimizing string search. We are discussing this today because the string searches can be a performance bottleneck in SQL Server searching. So for this, we can use indexes, also the full text searches, and also the computed columns, which means that we can reduce the column computation like substrings, concatenation, casting, like that when searching if we use computed columns. So we have to avoid the leading wildcards like pattern in large data sets. And next time we're going to discuss about this full text search. So I have prepared an example for demonstrate this. Let's move on to that. So I'm using the worldwide importers database for this one. It is also a publicly available database like same as the adventurers from Microsoft. So our problem is that users are looking for new arrival keyword in order lines descriptions, but the search is slow. So we are going to make it faster using the full text search. So I'll clear the DB cache first. This one also turn on the distribution file. And I'm first time using the light pattern to retrieve our data, search result. So let's see. So you saw that it took like a second, and also there are higher elapsed time and CPU time for that. So let's go to a new query window for enforce the full text search for this tool. This same to get the same result. So first we have to check that our SQL Server instance has installed the full text search, because when we install the SQL Server, the full text search doesn't comes default. We have to install it partially. So we have installed that. So we are going to create a full text catalog first. Full text catalog is the container that holds the full text indexes from multiple tables. So let's create that one also, and we are going to create the full text index for the description column in our order lines table. So let's create that also. So let me clear the database cache first before run our full text search query. So in here you can see we want to select the order lines and description columns from the order lines table. That contains this phrase URI. So we use the contains keyword, and there are other keywords we can use for full text search for various features. So we will use this one for this query. So let's see. So you can see it was faster than the previous light pattern, and also there's a different execution plan for this one. Also, you can see the logical reads are only 3, and also the CPU times and elapsed times are much lower here. So let's discuss how the full text search works. So when we create a full text index, as an example, in this cell, in the phrase in this cell will be divided into words, and if those will be position organized against their position. So this process is called organization, and you can see that black is against number 1 and orange is for number 2, and you can see the end word is missing. So, and also this word is also missing. So when we in the full text search, that these are called stop words. So when we get a full text search, that it doesn't include these common words for our full text index, because that also one reason is save space, and those are not much relevant to the searches that we are performing. So when we search this new arrival phrase, so it will also divide it into words, and the full text search will look for these tokens and the position. These tokens in the full text index. So when it found the new and arrival against an order line ID, So it will point that out, and also it will check the order of these keywords. So when the order is also correct, that it will retrieve the results we want. So I think you guys understood that also. So let's move to our slide. I think that's all from our presentation today. And if you guys have any questions, then we can discuss. Thank you very much for joining us today.